I'm going to add some fused multiply add instructions, starting with this VFMADD SS instruction for 132, 213, and 231. So all of these are just RVM operand encodings, and there's basically one VEX and one EVEX for each of the numbers here, where EVEX supports rounding and op masks and zeroing. So we'll just go to the encoder test assembly and do a VFMADD. This is 132 SS. Since it's RVM, I can just do XMM0, XMM1, XMM2, and then change this to a memory access. And then for the EVEX version, we'll just put some random op mask in with zeroing, and we'll add rounding to here as well. Then we've got 213 and 231. Let's just see if NASM's okay with that. Yeah, that's fine. So that's SS. SD is basically more of the same, but we just changed the mnemonic. Then we've got PS here. So PS has the same numbers, but we get support for YMM with the VEX version. And then EVEX has broadcasts as well as rounding on some of them. So rounding only happens on the ZMM ones. The other ones just support broadcasts. And it goes from XMM, YMM, and ZMM for all of them. So, okay. So I'll just copy one of these. So this is PS. So we've got XMM, which has, for the VEX version, just has RVM. And it looks like, yeah, it's just the same for the YMM version as well. So we'll just change this to YMM. But we have no rounding on the VEX versions here. So we'll just take off the rounding. Let's put these ones together. Okay. Then we've got EVEX, which doesn't have the rounding up until ZMM. So for EVEX, we'll just put an op mask on these. And we also need a broadcast as well. So this one is PS, so this will be 1 to 4. This one will be 1 to 8, and this one will be 1 to 16. And that covers all of the... Oh, this is XMM and YMM, actually, so... if we've got XMM here, this is EVEX, so that's XMM. This one should be YMM. And then this one should be ZMM. I think. So we'll just take that one away because that's one too many. Okay, so we got 3 for ZMM. ZMM needs the rounding test as well, though, actually, so we'll bring that one back and do rounding on this one. Or actually, we'll do rounding on this one up here. We'll just do rounding SAE. And then I think that's about it. So we've got XMM, YMM, and ZMM. They've each got rounding. Or they've each got a broadcast, and rounding only appears on ZMM. So then we just need to copy this for the other ones. Let's just make sure NASM's okay with what I've done. Yep, that's fine. Okay, so we'll change these to 213 and 231. Okay, so that's PS. Then we've got PD here. PD is the same. It's got rounding on the ZMM, but the element size has doubled, so we just need to change the broadcast for each of these to halve the number of lanes. So we've got PS here. Oh, this one is also PS. So we've got SS, SD, PS. Oh, this was the VEX version of things. Yeah, I need a VEX one for this as well. So this is 231. And we'll do the VEX version for 2. Oh, there's 2. Okay, this is 213. And then we've got a VEX version of 231 as well. Let's just make sure that's okay. Yep, okay. All right, so now we can copy all of these for PD. And anywhere that there's a broadcast in here, we just need to halve the number of lanes because the element size has doubled. So it goes to 8. Okay, that looks fine. So that's VFMADD. Then we've got VFMSUB, which should be the same. I think these also use rounding. I'll just check through them. Yeah, there's rounding there for the negative one. Yeah, I think this should all be the same. They're all RVM. Yeah. Okay, so we'll just copy all of these tests. And this time we'll change VFMADD into sub. So go all the way down here, change this to sub. Then we can copy all of these because the negative ones are also the same, they just have an N in the mnemonic. So instead of VFM, it's going to be VFNM. So let's just go and change all of these. To N. Okay, so now we can just generate the test case notation. So we'll take all of these. Oh, we've got some incorrect selection here. Okay, we want to go all the way down to here. Take all of these, remove the empty ones. Okay, that's better. Okay, let's go back to the semicolon. Generate the test notation. I think that all looks okay. And then we'll just align them all. Yeah, I think that's all okay as far as sizes go. Got X word, Y word, Z word. Okay, so let's just generate this listing again. And then the final thing to do is to go and take all of these mnemonics here. So this will be all of these ones. Let's just deduplicate them. And then we'll just separate these out by the suffix and the numbers, or just the suffix actually. Okay, let's take this over to the mnemonics here. I suppose we'll just edit with these ones up here. And then we just need to take these over to the name table, put them in here. Give each of them a name. Then we'll take them over to the forms table. And change all of these into empty form tables. Okay, let's just change these ones to that. Okay. So go test should fail immediately. Okay, so we'll start with VFMADD SS, which is this one. So VFMADD SS for 132 is going to match on only X word, but this is also VEX. So we've got family is VEX. The width that we're going to match on is X word. The op-n for this is op-n RVM. Op1 can be a VEC, op2 can be a VEC, and op3 can be a VEC or memory. Then we've got a prefix, which is 66 for this case. Then we've got a map, which is 38. And then the opcode itself is 99. Then we have an EVEX version, which is the same thing. The only difference being that this is EVEX and it supports op mask, zeroing. So we'll do OR with op mask and zeroing here. And then on the end one here, it also supports embedded rounding, which I think I did as ER. Yeah, ER. No broadcast on this one, so we can just leave that off. Okay, so that's correct for this one. Now we'll just move on to 213. So 213 is more of the same, but it's A9, and then we've got B9 for 231. So this one is 213, which is A9. And this is 231, which is B9. Okay, so now it's on to the SD version. So we'll just replace this. So this is no longer SS, this is SD. So SD here is exactly the same, but the W bit is set for all of them. So let's just find family over here. We'll just go to the end and add W1. Okay, so now we're on to the PS version, so packed single precision floats. So this one is, by the looks of it, more of the same. W is always 0. But this time, instead of 9989 or 99A9 and B9, we've got 8 instead. So we'll just copy these ones, put them over here, change the suffix to PS. So we've got PS here. And this one's going to need to match on more widths as well. So we'll just get rid of W1 first. Then out of these, we'll just change the final digit to 8. So this is going to mostly generate the right stuff, but it's not going to match some things yet. So each of these needs to support, for the VEX version, needs to support Y word as well. Then the EVEX one needs Y word and Z word. So we do Y word here and Z word. And then for Z word, we need to support broadcast, as well as rounding. I think it still has rounding. We'll take rounding off and just see. Let's do broadcast. Yeah, and then we still need rounding. Okay, so now we're on to PD, which is going to be more of the same. I imagine this is the same, but we have W set to 1. So we'll just change to PD here, and then let's just set W to 1 and see if that's correct. Yep, that's fine. Okay, so let's just copy all of these. And now we just need to change it for sub here. So we've got these VFMADD to change to sub. So what's the difference with sub? We've got SS. This is 9B, 8B, and BB. Okay. All right, so SS is basically changing to B on the end here. And it's probably going to be the same for all of these, so I'll just go and get these ones here and change them to B. These ones probably will also change to B, so we'll change those. Then for PS, let's see, where's PS? This is 9A, AA, and BA. So instead of the 8 on the end here, we have A, and probably the same for this one as well. So we'll just change this to A, and we'll just do a test. Okay, that's all correct. So let's go now and copy all of these, add and sub. We'll go all the way up to here. And we'll replace all of these negative ones and just rename the indices here. So this is add, this is where it starts, so we've got VF. We'll just go and take all of these VF strings and put an N on them. So for the negative ones, we got VFNMADD here. So this is D changing to D, everything else is the same. Okay, so instead of 9, this is now D. I assume it's going to be the same here as well, but we'll just check. So with SD, yep, this is also changing to D. Then PS is changing to C or as the last digit. So that becomes C, and this one will also probably become C as well. Okay. Okay, let's go and look at FNSUB SS. So this one is changing to F, F, and then E. Okay. So these ones, instead of 9B, etc., these are changing to F. This one will also change to F. And then the PS and PD ones will change from A to E. Okay, so that was just some VFMADD and VFMSUB instructions.